We have normally a transformer, as shown in the blue curve here, is for each half cycle, the core is getting magnetized in one direction or the other. The problem that happens is when we experience the quasi-DC current from the solar storm, basically we have a shift in that the magnetizing current. And what ends up happening here is we get a DC offset in the waveform. And basically it's going to drive the core in saturation in one direction or the other. What's happening here is we have a very large short duration pulse of very high magnitude, which causes the core to go into saturation. And when that core goes into saturation, the core starts to produce large amounts of harmonic current. It's also increasing the reactive loading on the system. And by that, I mean when the core is in saturation, what it's going to do is the core can actually start to consume VARs. So if the core of the transformer is consuming VARs at the same time we're producing harmonic currents, that's where some of the instability of the system come in. And, the desire to keep everybody in power and keep the lights on. This is where FERC got involved in their Order 830. They came out with a few requirements and basically gave direction to NERC, creating a system model for how your system is going to perform during the presence of that GIC.